Moving ahead from this particular topic, what we have learned yesterday, we came to know that there are four steps involved in problem solving, which we have seen in detail yesterday. Analyzing the problem and then developing an algorithm, then coding, and then finally testing it. Whenever you have a solution, the solution may be ways. There may be multiple solutions for a given problem. And whenever you are trying to get to a conclusion, which of the algorithm is best one, you have to look into its. So you classify the algorithm into good or bad based on the first characteristics that it should have is it should.
Sir, your voice.
Is it audible now?
No, sir, your voice is like breaking.
It's breaking even now.
Yes.
Okay. Test it out. Is my voice clear now?
Yes, sir.
Yes, sir.
Better than the previous one?
Yes, sir.
Okay, fine. So,
Yes, sir.
algorithm is nothing but a set of steps, exact steps, right? So, whenever we are getting to a conclusion whether a given algorithm is better than the previous one, we have to look into its characteristics. And the first characteristic is that it should have a limited number of steps. Algorithm cannot have an infinite number of steps. We should have some 4, 5, or 3, or 9, or 10 number of steps should be there. So based on its characteristics, we will try to classify the algorithms into good or bad categories. The first characteristics is precision, the number of steps that are needed to execute the algorithm. Second is each step should be unique. Third one was finiteness. And fourth and fifth were what type of inputs you are going to take for executing the algorithm and is the expected output of that particular algorithm. So we have seen all those things in detail yesterday, and I have given you a particular brief overview about how an algorithm looks like. If you get into the previous slide, the green color matter over here was nothing but the algorithm that we have seen yesterday. And this algorithm was doing nothing but calculating the square of a given number. So what basically in the first step we are doing is we are inputting a number, whatever number the user wants to calculate its square, and putting it or storing it into a memory named as num. And now when the value is there inside the variable num, we are calculating or computing its num into num, basically which gives us the square, and storing it into another variable called as square. And once the square value is computed, our task is over. We are trying to print it out. So basically, there are only 3 steps in that algorithm. And whenever we want to put this matter in front of some higher officials, or when you want to explain it to someone who doesn't has any computation knowledge, you have to represent to them in a basic format, in a simplest format. And one of the ways of representing algorithms was flowchart. The other one is pseudocode. Pseudocode is very little complex. It is not as simple as that of flowchart, but flowchart has symbolic notations, drawings, and that will give a clear-cut idea about how your program is executing it, or how is it going to solve the problem. So what is the definition? And here a sample representation of what we have done earlier as an algorithm for calculating square. I have given you a flowchart here. Now, we have seen what is the difference between algorithm and a flowchart. And after that, we are going to start today actual topic. Having a brief introduction about what is an algorithm, now let us focus on program and how it differs from algorithm. As we know that algorithm is nothing but a finite set of instructions that specify a sequence of operations that are needed to execute or that are needed to be carried out in order to solve a particular problem. Right? But on the other hand, a program is also a set of instructions. But these instructions instructions are to be executed on the computer. So it should be written in a format or a language which is understood by the computer, which we call in general as programming language. The language which a computer usually understands is usually called as programming language. Algorithm is written in a plain English language, but whereas a program is written only and only in programming language. This is the key difference between them. So when we talk about a program, it's nothing but a concrete expression of an algorithm in a particular programming language. Now, there are multiple programming languages available in the market. We can say basically there are thousands of programming languages. Which one is the best? We cannot decide it because each one has its own usage. On a fundamental level, if we want to start learning programming languages, what should be the first language which we should prefer? And the first language which we have to adopt should also contain a lot of syntax and a lot of any language will have its own grammar. So whatever we are preferring to start learning, it should be very similar to other languages. It should give a foundation for other languages. And the language which is very suitable for it is C language. That's why in our syllabus we are starting with C language. Now, let's get back to the subject. Given a problem to solve, whenever a programmer looks at a particular problem, it will first design a plan to solve it. That designing phase will produce algorithm. The plan that is being produced is nothing but algorithm. But once the plan is there, its implementation is nothing but a program. So many of the lectures or many of the textbooks they will confuse you. Write an algorithm, write a program for a given problem. Algorithm and program both are two different entities. They are two different concepts. That's why the differences have been highlighted over here. We can basically consider an algorithm is like a general idea in our mind to get a solution for a problem. Whereas when we are talking about a program, we should be cautious that this program is going to be executed on a computer. So it will have lots of tasks to be completed to execute the program. As usual, a program can implement one or more algorithms, maybe multiple tasks, and for each task, one algorithm may have been written, and all those tasks combined together will give a solution for a particular. So if you have multiple algorithms, a program can implement one or more algorithms in itself, or not even have an algorithm. Suppose there is a very simple task. It doesn't need a drawing, it doesn't need an idea to be framed. Just simply it can execute it. For example, calculation of addition of two numbers. It's a very simple task. We need not write an English sentence that take one variable, then store the value, then take another variable, store the value. Start writing the program. Simple. I have kept critical points so that you can write in your examination. Just go through it. I hope it's self-explanatory. If you feel any point in the previous slide where you have not understood, you can easily ask me. Now, in this particular slide, I have kept a slip test for you, which I'll keep a deadline shortly. I'll explain, post it in the Google Classroom, what is the deadline and how many marks will be awarded for that one. But basically, you have to, in the previous slide, I have kept a few differences between an algorithm and a program, right? What you have to do in this particular slip test is you have to pick up those differences to a tabular sheet. The algorithm and for the program. What can be the differences between them? Right, any 5 of them. So coming on for programs, a program, before we go into it, that one, let us try to know what is a language. Language Language is a medium of communication between two entities. When we are talking specifically about a programming language, we are talking about two entities. The first one is the person itself or the developer. The second one is the computer. When we are talking with the computer, we have to speak in the language or in the terminologies which the computer can understand. But honestly speaking, computer is just a electronic device which doesn't understand any English, Telugu, Hindi, or any other language except one and zeros. Except ones and zeros. It doesn't understand anything. So, can we speak to a computer in just ones and zeros? No, it's not possible. That's why programs or programming languages have been developed into high level languages and low level languages. Let's get to know what exactly is high level language and a low level language. Any programming language defines a set of instructions that are compiled together to perform a specific task. And that task, just focus on this one. The task is to be executed by the CPU, which is nothing but the processor. And this processor understands only and only ones and zeros. So, processor is your hardware, understands only ones and zeros, but we as a human being, we cannot write in ones and zeros. What we have to do then? Many researchers have developed various languages such as C, C++, Pascal, Fortran, and many other Java, Oracle. All those languages are existing. They have developed these languages which are high level languages. High level languages in the sense, these are languages which we can use and communicate with. For example, English. These languages have syntaxes and wordings which are just like English language words and syntaxes. But computer doesn't understand this language. Computer doesn't understand it. So what to do? We will convert this high level language into intermediary language, which will contain some ones and zeros as well as some English wordings. That intermediary language is nothing but assembly language. And later on, this assembly language will be completely converted into ones and zeros, and this ones and zeros will be directly understood by the underlying hardware. So, programming language contains a unique set of keywords and syntaxes. Keywords are the wordings which our whole programming language is built up. These words have their internal meaning, and these internal meanings are internally stored in the converting tool, which will convert the assembly language. So these keywords are just like words which are predefined and into the software which is going to convert the high level language into assembly level language. And along with the wordings, we should have certain syntaxes to be followed. Syntax is just like grammar. In English, we have words and words combined together with grammatical sentences, right? So we have got keywords and we have got syntax to use those keywords. Now, as you know, there are thousands of that are available. Some of the languages are written for direct ones and zeros, which are very difficult for us to understand and write. Some are the programming languages which are written for assembly level languages. Some programming languages have been written for high level languages, such as C, C++, Pascal, and Fortran, and Java. So, some of the programming languages directly interact with the hardware. Some will try to give a abstraction to the hardware. Abstraction means it will hide the internal implementation of machine language to the hardware. Some will hide it more. So this hiding or abstraction, based on these abstractions, the languages, programming languages have been classified into low level and high level. So let's get to know about low level languages. As we have spoken about it, with low level languages is a programming language that provides no abstraction from the hardware, represented in only zeros and ones. Basically, the low-level languages are classified into two: machine level and assembly level. This machine level will contain certain wordings. Machine level will contain only and only zeros and ones. The syntax, the keywords, and everything is built up of zeros and ones. For example, let us take my name. If my name in machine level language, after my name Asmat, let us take a letter A inside it. This letter A will be represented as numerical value 65, and this 65 again will be converted into zeros and ones. So can I remember my complete name in zeros and ones? No, it's very difficult, right? But in case of assembly level language, some sort of wordings which are most, for example, add, subtract, multiply, move, these wordings are given a nickname, and this nickname is called as mnemonic. This nickname is called as mnemonic, and this mnemonic is understood by the software which is going to convert the assembly language into machine level language. So when we come for high level language, it's again a programming language, but this is of particular type. Remember this. It is independent of a particular type of computer. That means the language, high level language, is going to contain those terminologies which are very familiar for a human being to adopt. So high level languages will abstract it more in detail. Just give me 1 minute, ma. I'm getting a call.
Sir, we are unable to hear your voice, sir.
Yeah, ma. Is it audible now?
Yes, sir.
Okay. So we were talking about high level language.
Yes,
Right?
sir.
So this high level language is going to be written in a format which a human being can speak about, right? So
Right,
usually
sir.
we're speaking in English, and in English, when we are talking, can it be understood by the computer? No. So computer understands only zeros and ones. That's why we require a software, a tool. We require a software or a tool which is called as compiler, which will basically translate a high level language into low level language. Okay. So whenever we are having any high level language, we require a compiler which will translate the high level language into low level language. Now, what can be the advantage of high level language? Why we are using a translator? It will delay the programming. No, there are certain advantages. As we know that we cannot directly communicate with computer in zeros and ones, it's very difficult for us. High level language is very readable. We can easily, as well as if any error happens, we can easily, because it's there just like English. Okay. Secondly, it's portable. Portable in the sense you're not making any program which is dependent on the computer. Depending on the type of computer, in this sense, there are basically two types of computers in the market. One type of computer is 86-bit computer, second is 64-bit computer. Second one is based on the operating system. You have got Windows operating system computers, you have got Linux operating system computers, you have got Sun Solaris computers, you have got various other operating systems available. If you are writing directly in a low-level language, you have to write the same program for multiple types of computers. Whereas if you write a program using high-level language, you'll write only one program and you'll execute it onto different systems and it will work. There is no problem. This portability onto multiple systems, the ability to execute it onto multiple systems is called as portability. So high-level language is portable. These languages are machine independent. That's why we are going to learn it. Here I have kept differences between low level and high level language. Please go through them. We have almost done up with all the points. I'm not going to explain it. I will just share the slides, go through it, and I will conduct assignments from it. Okay. Now coming on for compiler and assembler, linker, and loader. Remember, I said whenever we are writing a program in high level language, we need a software which will translate our high level language into machine level language. Software is called as compiler. The software is called as compiler. It will contain multiple components inside it. Each component will perform a specific task. So let us try to understand it. So let us first begin with our program, which we will call it as source code. This program will be usually given to a compiler for converting or translating it into machine level language. So whenever we are giving this particular source program, usually it will be written in C language. Say C language as a high level language. We'll save the program as program.c, prg.c. Remember the extension .c will be there. Okay. Once we give it to compiler, what compiler will do is whatever C program is written, keywords and syntaxes, we're trying to pick up those keywords and syntaxes from preprocessor directives. It will pick up these preprocessor directives, try to understand what is the code that has been written here, match the syntaxes, get to know if there are any errors or not. If the error is there, again we have to remove those errors and compile it back again. If there are no further errors, what it will do is it will send this particular translated program, translated one, to assembler. Assembler will do is it will take whatever targeted assembly language converted or translated assembly language code is there. It will take that one. It will convert, pass it to linker by converting this assembly language code to object level code. Here, object level code will depend on which computer you are trying to compile. So your prg.c is getting converted into prg.obj. This is object code. Now what the linker will do is it will try to link up all the operating system required files along with our program. Where additional library files are required, it will link our program together with those into loader. This loader, what it will do is it will take this obj file linked up with library files called as prg.exe. It will take this file prg.exe, pass it onto memory. This memory is nothing but your RAM. Here, you cannot execute any program unless and until it is brought into RAM memory. The program is executed by your processor only and only when it comes into memory. So what loader will do is it will take the prg.exe and pass it on to memory to make sure that there is sufficient memory space available, and it will pass that program into the RAM memory. Now from the RAM memory, the prg.exe is taken and it will be passed on to processor. This processor, it will start executing the program, and if any inputs are to be taken from the keyboard or mouse or something like that, it will take the input from the user and generate the output and display it back onto the output devices. So this sequential flow should be on your fingertips. You should by heart it out. So let's quickly revise it back once again. We have our basic source code, which is plain English language code. Usually, this source code will be understood by the computer, so it needs a software which will translate it into machine language. That software is called as compiler. Okay. This compiler, what it will do, it will take the C language, prg.c, pass it on, combine it along with its preprocessor directives, know what are the syntaxes, get to know is there any error or not. If there is any error, it will let us know that what is the error. Once we resolve the error and again compile it out, once all the errors are free in our prg.c, it will pass it on to assembler. What assembler will do, it will take the particular targeted assembly language code, pass it on to linker. What linker will do, linker will try to take this prg.obj file, which has been passed by the assembler, and add on some additional files which are required for execution purpose on our operating system, pass it on to loader. This loader will take this prg.exe file, which has been converted in by prg.obj along with the additional files. It will pass it on to memory. Memory will take prg.exe and pass it on to processor. Processor will take if any inputs are to be taken from the user and generates the output displayed on the output device. So all those definitions, I have written it separately here. Please go through them along with what it does individually. I have written it here. So your task is to go through these definitions for what is assembler, what is compiler, what is it going to do, and I'll be keeping a slip test in backing these definitions. Right now I'm not explaining because you can get to know what exactly it is. It's very clear here. We have clearly understood it there. Same thing when it comes in a different terminology. Sometimes in exams, they will ask about of compiler, assembler, and linker loader. They will say, what is a source code, assembly code, object code, and machine code? Explain about them. So let's try to understand that. This assembly code or high-level code are called as source codes. Yes, executable file or library files in bytecode are called as machine codes. This whole machine codes and bytecodes are called as object codes. So don't get confused about what they are. It's very simple. It's very simple. Let's get back to this diagram. Whenever we are writing any C language, that C language program is called as source file. It is in plain English usually. Okay. This C file, let us say hello.c. If it is written in C language, it is hello.c. If it is written in C++ language, which is next level language to C, it is called as hello.cpp. Okay, let's concentrate only on hello.c. This source file is first pre-processed to get to know is there any error or not. If there is no error, it will be converted into hello.c to hello.i. What will be the extension converting from C to I? Okay. Once this conversion is done, after checking for all the errors and syntactical details, it will be passed on to C compiler. C compiler will compile it into assembly level language code. Okay. This assembly level language code will be hello.s. So .c has been converted into .s, .i, and .i is converted into .s. Okay. This assembly level language can be understood by the assembler only. Okay, so it is passed on to assembler, which will convert it into object code file. This object code file is an internal representation